Okay, hello Cloud Gurus and welcome to this section of the course. In this lecture we're going to look at Databases 101. You could skip this lecture if you are a DB admin, if you know the difference between a relational database, a non-relational database, what a data warehouse is, etc. But if you are new to AWS and you don't know about all the AWS products for databases, I would recommend that you watch this. So what is a relational database? Well, they've been around for a very long time, basically since the 70s. And the best way to think of a relational database is to think of a spreadsheet. So just like Excel or Google Sheets, essentially a database consists of tables. So if you think of a spreadsheet in Excel, you've got your workbook and inside you've got different sheets. And those sheets are made up of two things. They're basically made up of rows and fields. And your fields are going to be your columns. So if you think of an Excel file, you've got the file itself, which holds everything inside it. Then you've got different workbooks, which are going to be your different tables. And in those workbooks, you've got rows and columns. So that's all a relational database is. So let's have a look at an example of a relational database. So here is a good example. It's got 4 fields. So we've got ID, we've got first name, we've got surname, and we've got gender. And then we've got 4 rows or 4 entries into this database. So the first one is me. So my student ID, which might be unique, is number 1. And then my first name is Ryan, surname Cronenberg, and gender male. And if you have a look at the different categories, so if we look at the different columns, ID, the data is always going to be the same. So you're always going to have a numerical value in there. Same with first name, that's always going to be alphanumeric, or actually just might have just normal characters. So same with the surname and same with the gender. You might have other data inside there. It might be something like address, which would be alphanumeric, so it would have both numbers and letters, etc., etc. And the reason that's important is we'll come to that in the data warehousing section as to how data warehouses work. But just take a note that this is a typical sort of database. So it's very, very simple. 4 fields, and then we've got 4 different rows within those fields. I want you to think about what happens if we were to add something else. Maybe we need to add someone's postcode, but maybe we only want to do it for John. Maybe we don't want to do it for Erica or for Julia because they live in Ireland. And believe it or not, Ireland does not have postcodes. So how would you do that in a relational database? Well, you would have to add a whole new field, so a whole new column, and that would completely change the table. So you would have a new column in there, and that would completely change the table. You couldn't just add it in for Ryan and for John and leave out Julia and Erica because they live in Ireland. And this is sort of a problem with relational databases, is that you need to understand all your fields before you create the table. Otherwise, when you go and create that table and you need to add additional fields, you're going to have to update the entire table. So let's talk about the different relational database types. I'm sure we've all know SQL Server, it's a Microsoft product. That's basically what drives a lot of enterprises. So a lot of accounting software is runs off SQL Server. You name it, basically. A whole bunch of different database products or database applications use SQL Server as the back end. We then have Oracle. Oracle's been around for an awful long time. It's also a very popular relational database. Typically will be used by the big enterprises, but can be used by other businesses as well. Then have MySQL. MySQL is an open source relational database, and it is free to download and to use. It's very, very popular, especially in the developer community. Same with PostgreSQL. We then have Amazon's proprietary database called Amazon Aurora, which we're going to cover off. Aurora is basically comes in 2 flavors right now. So you have MySQL as well as PostgreSQL. So if you've got an existing MySQL database or PostgreSQL database, you can import them into Aurora. Aurora is basically has massive performance and really, really good redundancy. So this is Amazon's own relational database. It's relatively new. It's about 2 or 3 years old. We then have MariaDB. MariaDB is another relational database, again, that's quite popular in the developer community. So those are the 6 different types of relational databases that are available to us on Amazon Web Services. Now in this course, we're going to be using MySQL just because it is the easiest one to use. You can use whatever it is you like. Just be aware that you will be tested on RDS as a whole, and they will also will will ask you some Aurora questions as well. In terms of non-relational databases, so let's have a look at the structure. We've got a database, and inside that database, we've got a collection, and inside a collection, we've got a document, and inside that document, we've got key value pairs. And you might be thinking, whoa, what does that mean? Well, let's have a look at what this means in a relational sense. So a collection is simply just a table. A document is simply just a row, and inside that document, you're going to have your key value pairs, and these are simply fields. Now, the cool thing about non-relational databases is, we'll go back to my example of people in Ireland not having postcodes, and then people around the rest of the world having postcodes. You can go and create a new database and have a new collection in there, and when you go in and you add a new document, you can add as many key value pairs or as many fields to that document as you want. The preceding documents don't dictate how many fields there are. So you can go in and add postcodes for your non-Irish citizens, but at the same time, when you create a document for your, for each Irish person, you don't have to have a key value pair as being a postcode. And for that reason, NoSQL or non-relational databases, you don't need to know how many fields or how many columns you need when you build these things. It's completely flexible, and they are very, very popular. They're becoming more and more popular in the developer community. So what does it look like? Well, Amazon's NoSQL database offering is DynamoDB, and in DynamoDB, you put into JSON format. So JSON just looks like this. So we've got our ID. These are our key value pairs. So our ID might be 51262, etc., etc. And this is our unique ID. We then have our first name. We then have our surname. We then have our age. The other cool thing is we can actually nest values. So we can have address, and inside that address, we can have unique key value pairs. So we could have street, we could have suburb, etc. And it comes in this JSON-styled format. For those of you familiar with Python, it's just the same as dictionaries, essentially. So that is how the data is stored inside DynamoDB. We're going to see that coming up in a lab. So we've covered off relational databases. We've covered off non-relational databases. Let's move on to data warehousing. So what's data warehousing? Well, this is used for business intelligence. And you've got tools like Cognos, Jaspersoft, SQL Server Reporting Services, Oracle Hyperion, SAP NetWeaver, etc., etc. And these are big databases that are basically used to pull in very large and complex data sets. And it's usually used by management to do queries on data, such as current performance targets, might be current sales, etc. And we'll have a look at an example of that in a second. But before we do, I just want to go on to OLTP versus OLAP. So you might hear this thrown around in the database community. OLTP simply stands for online transaction processing, and this is a little bit different from online analytics processing, or OLAP, and it's just in terms of the type of queries that you're going to run with. So let's look at an OLTP example. This might be order number 2120121, and you just want to say select order number 2120121, and it's going to pull up a row of data, and that data may contain things like your name, it might contain the date of the order, the address to deliver the order to, the delivery status, etc. So that would be OLTP. OLTP, you can, if you think about just online shopping carts, when you go and order something, you're creating an OLTP transaction. OLAP, or online analytics processing, is what we use for data warehousing, which is what I was talking about earlier. So this is a good example. Maybe management want to know the net profit for EMEA, so that's Europe, Middle East, and Africa, as well as the Pacific, for a digital radio product. So let's say it's a physical digital radio. In order to do that, you have to pull in large numbers of records. You're going to need to understand the number of radios sold in EMEA, the number of radios sold in the Pacific, the unit cost of the radio in each region, the sales price of each radio, the sales price minus the unit cost. You're going to have to do that as a calculation. And basically, this is going to put a lot of stress on your database. And so what you really want to do is, of course, you don't want to run that on your production database. You don't want to run that on your online store because that's going to really hammer the database. You want it to be ticking along doing all the OLTP transactions. So what you might do is export all of your, your production database into a OLAP database or a data warehouse where you would run these queries against, and that wouldn't impact your production database. So you could pull out all the management information that you need to know using a data warehouse. And so that's all a data warehouse is. They're designed actually quite differently from an architectural point of view from both a database perspective and an infrastructure layer. And again, we're going to cover that in the Redshift section of the course. Then finally, moving on, we just need to talk about one last thing, which is Elasticache. And Elasticache is basically a web service that makes it easy to deploy, operate, and scale an in-memory cache in the cloud. So what does that actually mean? Well, basically, this allows you to retrieve information a lot quicker. So it's going to allow you to retrieve information from fast-managed in-memory caches instead of relying on your slower disk-based databases. So instead of relying on your web servers. So I'll give you an example. Maybe you sell, maybe look at your homepage, and let's say you sell t-shirts, and you've always got your top 10 bestsellers on the main homepage. Now, when someone goes and visits that, there's two ways they could do this. They could go to the web server. The web server pulls up the top 10 selling products from the database server and runs a SQL query every single time for every single user who visits that page. Now, that is not actually a good use of your web server or your database server's time because the top 10 selling items might not change all that much. They might change maybe once a week or something like that. So what you can do is you can cache that information. You can cache the top 10 selling ones so that your web server gets it from Elasticache rather than getting it from the database server. And that frees up your database server to return more valuable information. So be a lot faster when people are, placing orders, for example. So Elasticache, we are going to cover in its own lecture. It supports two open source in-memory caching engines, which is Memcached and Redis. Where this really features heavily is in the Developer Associate course. In the Solutions Architect Associate course, you just have to understand what Elasticache is at a very high level and where you would use it. And, you would use it exactly where I just gave you that example. If your database, your primary or your production database is under a lot of load, you want to use Elasticache to relieve your database of that load. So the most common queries are cached in Elasticache, and that frees up your database server to do other things. So we've learned basically all the different types of databases for AWS. Let's just summarize what they are. So we've got RDS, which is online transaction processing. That consists of SQL Server, MySQL, PostgreSQL, Oracle, Aurora, and MariaDB. Throughout most of this course, we'll be using MySQL, but you do need to understand what Aurora is at a high level and the pros. And there aren't many cons of Aurora apart from it. Is a little bit more expensive than running it on MySQL, but you get a lot better performance and you get a lot better disaster recovery. So in your exam, what it's going to focus on is mostly just RDS, and then you're also going to have some Aurora questions in there as well. We've got DynamoDB. DynamoDB is Amazon's NoSQL database. This features extremely heavily inside the Developer Associate one. It's pretty much knowing DynamoDB inside out is your key to passing the Developer Associate. Does not come up all that much in the Solutions Architect Associate, but you do need to know some basic things, such as that it's Amazon's NoSQL database in the cloud. We then have Redshift. So Redshift is Amazon's data warehouse. It's for online analytics processing. Again, we're going to have a whole lecture on that. We're going to look at the architecture. Just understand the use case for Redshift is where you're running those really, really complex queries. We don't want to run those on our production databases. We want to basically take a copy of our production database, put it into a Redshift cluster, and then go and hammer the Redshift cluster so our production database doesn't get all the performance hit. We then have Elasticache, and again, Elasticache is very high level in the Solutions Architect Associate course. You just have to understand essentially what it is. In the developer exam, it's featured quite heavily. You'll need to understand the two different engines and where you should use one over the other. We do cover that in the developer exam. So that is it for this lecture, guys. In the next lecture, we're going to start getting our hands dirty by launching our first RDS instance. So if you've got the time, please join me in the next lecture. Thank you.